Hi, in this video I'll be showing you how to solve FRQ 2005 number 6. Let f be a function with derivatives of all orders for which f of 2 is 7. When n is odd, the nth derivative of f at x equals 2 is 0. When n is even and n is greater than or equal to 2, the nth derivative of f at x equals 2 is n minus 1 factorial over 3 to the nth. That was a lot of confusing information, so I would write out the important parts of the problem. You have the first term, f of 2 is 7. You have the nth derivative of f when it's odd, which is 0, and when it's even, which is this formula that they gave us. What can make this problem seem a little hard is the n is odd, n is even thing, but we'll follow the same process as always. Part A says, write the 6th-degree Taylor polynomial for f about x equals 2. A Taylor polynomial looks like this. You have the 0th derivative of f times x minus 2 raised to the 0 over 0
factorial
plus the first derivative of f times x minus 2 raised to the 1 over 1 factorial plus the second derivative of f x minus 2 squared over 2 factorial, and so on. The reason why it has an x minus 2 squared is because the problem says that you need the Taylor polynomial about x equals 2. So we need to solve for the derivatives of f. Because it asks for the 6th degree, we will stop at f6 prime of n. For the odds, it's 0, and for the evens, you plug n into the formula they gave us. That was this n minus 1 factorial over 3 to the n power. Then we plug those values in to get the Taylor series. So you have the first term, which is 7. The second term, that's f prime of 2 times x minus 2, which is just 0. And then the third term, which is f double prime of 2 over 2 factorial times x minus 2 squared. So f double prime of 2 is over here, that's 1 over 3 squared over 2 factorial times the x minus 2 squared, and you'll keep doing that until you get to the 6th power. You get a point for writing the polynomial about x equals 2 and 2 points for having the 6th degree Taylor polynomial correct. Part B says, in the Taylor series for f about x equals 2, what is the coefficient of x minus 2 raised to the 2n? We use our Taylor series from before. First, it's important to recognize that this exponent is 2n. You'll notice that the numerator is always 1 less than this exponent value. If this exponent value is 2n, then this numerator will be 2n minus 1 factorial. This value and this value are both also always equal to the exponent of x. So you have 3 raised to the power of 2n times 2n factorial in the denominator. After you simplify, you get 1 over 3 raised to the 2n times 2n. In part B, you have to be careful not to accidentally treat the exponent of x as n instead of 2n. And you get 1 point for getting the coefficient right. Part C asks you to find the interval of convergence about the Taylor series for f about x equals 2. The first thing you want to do is write the Taylor series. You have the coefficient from the previous problem and the x minus 2 raised to the 2n. Now, if you just use this, you'll get the problem wrong because this series is wrong. You have to remember that n must be greater than or equal to 2 for this even function to apply. N is 1 is fine because there are no limitations on the domain of n when n is odd. But that still leaves behind the question of what happens when n is 0. But luckily we're given that. When n is 0, f of 2 is 7. So we start with 7 and then add on the rest of the series, going from 1 to infinity. Now, if you didn't remember that n had to be greater than or equal to 2 for the even function to apply, then the best thing for you to do would be to check this first term. If we were to plug in n,
equals 0,
we would have a 0 in the denominator instead of a 7, which we know to be the first term. So if that happened, then you would simply take out the 7 and go from 1 to infinity. After you get here, the problem is pretty straightforward. Just apply the ratio test. So we plug in n plus 1 for n and divide by the original and take the limit as n approaches infinity. After you cancel terms and take the limit, you get x minus 2 squared over 9. The absolute value of quantity x minus 2 squared over 9 has to be less than 1 for the series to converge. So you just continue solving this, and you get that x is between -1 and 5. Now we have to test endpoints. To do that, plug your endpoint values into the series. When x equals -1, you end up getting the series 1 over 2n, which diverges by p series. When x equals 5, you also get the series 1 over 2n, which diverges by p series. So, your interval of convergence is -1 to 5 with soft brackets. In this part, you get points for setting up the ratio, finding the limit, finding the first interval of convergence, checking endpoints, and getting the correct final answer. So if by chance you forget to check the endpoints and you technically still get the correct answer, you're still missing the checking endpoints point. Gotta remember to check your endpoints. This sort of a problem is pretty easy, mostly because it's standard, and we've seen it a lot of times in class and on the AP test that we recently took. Thanks for watching. If you want more help, you can go to AP Central Calc PC and look at the released FRQs. Number 6 will be the series problem most of the time.